The radio just arrived. The radio project that I said I'm going to be doing. We're going to unbox it now. This will be part 1. It is a Motorola 5A1. It's a little bit larger than the ones that I normally work on, which I have difficulty because they're small. From what I have seen, and there is one YouTube video on this model, if you remove the speaker, you can pretty well get access to the entire underside of the chassis. Like I say, it's a Model 5A1 Motorola battery-operated radio. We're going to open the box. Yes, I know I'm a glutton for radios I like, but I can't see to work on them. But we're hoping that we can get one that I can work on, and we're going to give it a try. Okay. Packed well. It's small. It's strictly battery, and it takes 2 D cells instead of 1, and a 67.5 volt battery, as most of these size radios take. It's got the maroon crinkle finish, which I cannot seem to get the paint for exactly. I still got 2 Motorola, a different model that I've made videos on, that are working, that I did work on, but their cases never got painted. That case looks better than it does on the video. The handle's bad, so we'll probably just cut the leather off of there and not worry about that. And there it is. Volume control, channel selector, cover's in nice shape. And let's see. How this opens here. Okay. There's an awful reflection. I cannot tell if I'm in camera. I'll have to check that when I'm editing it. But it's a Model 5A1, typical 4-tube radio. And from what I've seen on one YouTube video, there's only one YouTube video on the Motorola 5A1. And I got the SAMs, as I showed you in the beginning of this section of the video. And it's much clearer than the downloaded stuff that I get off of line. And it tells you how to remove the cabinet. And the cabinet is not as bad as I thought. I mean, it needs to be redone, but there is a procedure for getting it out. It takes 2 D cells, and there is a little corrosion on the copper contacts, but it don't look that bad, and it just, I'm pretty sure it's D cells that fit in there. Yep, they do, and you got a strap here you put down in here so you can pull them out. So that's very, very important, because it'd be an awful job getting out if you didn't have that. And it looks good. It looks like we got grill cloth in there. I don't know if you can see that. Let me take you off the tripod here. Actually, we got you on the tripod, but we better view. Once you get the case off and you get to disconnect the speaker, getting at the bottom of the chassis to replace the components didn't look like it was going to be too bad of a job. Right here, where my finger's pointing, fingers were made before pointers. I just can't locate my pointer right now, so this will do. There is either 3 or 4 caps. 1.02, 3.02s and 1.05. According to the schematic, I guess there's different models. Some have 4 capacitors in here, and some have 5, I believe. I'm not positive. But the video, it's on YouTube. The guy shows he melts these right out. I just can't find my heat guns anymore. They just vanished. And then you just replace them in here. But what I would probably do first is to try to fire it up. The way it is, cleaning the contacts over here, down on the right side, and we got to see what kind of contacts there are on the left side. We'll do that first off camera, and we'll see if it works at all, and I don't expect it to, of course. Now, my experience with these radios, the ones I have worked on and did successfully restore them, they are city radios. They're basically for local reception only. They're not a DX type radio. So let me go clean these, and let's see if we can get a couple of D cells in here. And using my power supply over there, the Becker or the Belcher or whatever it's called, that I restored, and we'll put 67, 68 volts on it and see what we got. Stand by. This is too stiff to be able to fix. A lot of these handles on most equipment that I have seen have a metal band inside. This don't. So I'm going to just cut it off and not worry about the handle until later when I do the cabinet. And probably the way I'm going to do it is probably just locate a draw pull or something, handle, and put it in there, or we may just cut it off, which you're going to do anyways, and just leave, these hooks, these metal things in here. When I paint the cabinet, which I'm not too worried about it at this time. So I'd have to look at the SAMs because I can read the instructions better as to how to get the cabinet free from the chassis, or the chassis free from the cabinet, however you want to say it. But before we do anything, I just want to put a couple of D cells in here. The D cells I have are not alkaline, and but they'll be all right for a test. I will put the meter on them and make sure that they are at least 1.5 volts. I've tried them on other radios before. So for trying out, I can do that. Or I can use my big power supply, which I'm going to do anyways, to put the 67.5 volts or 68 volts onto the B battery terminal, and the A battery, which of course is two D cells in parallel, will be 1.5 volts because they're in parallel, not series. And that's what we're going to do there. So I'm going to set you up on a tripod, and we're going to just put the batteries in, and we'll put the power supply here, and we'll have the cover open, and we're just going to try it out. I don't expect it to work at all, but I want to just see, and then we'll take it out of the case and we'll start replacing capacitors. You've got an electrolytic here. As I recall, I think it's only a 10 microfarad. So the new ones nowadays are a lot smaller. That's easy to get to, and hopefully after I get the chassis out of the case, I can get the speaker disconnected. We'll do all that off camera. But right now, let's just try to see if we can get some life out of it the way it is. We'll hook it up to the power supply and drop 2 D cells in it, and we'll see what happens. Okay, we're going to take this out of the cabinet. It has a direct short, even with the cover closed, which has a switch, of course. So it pegged the needle here, even when I got it down to 10 volts. So it's got a direct short here. So we're going to take it out of the case. We're going to do that off camera. And we'll be back. Okay, to remove the case, it says remove screws A, B, C, and D. Well, I only see 3 screws. I remove this one, this one, and this one, and there is nothing on the bottom. Okay. Now, we're going to do this off camera. The diagram that I'm working with is out of the stuff that I downloaded. This is from the writer's manual. Unfortunately, the Sam's PhotoFact, which I ordered on eBay that I showed you at the beginning of this video, does not show that. This tiny, tiny, tiny print right up here, not very legible, remove screws A, B, C, and D. There's a screw on the left side of the unit, there's a screw on the top, and there's a screw on the right. No other screws there, so there is not a 4th screw yet, but I am going to be looking. Okay, I got it. There was a 1/4-inch nut over here, 1/4-inch screw, I should say, and a very, 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 very tight fit on the outer ring here. But the thing is, the diagram, which is very, very tiny and very, almost unreadable, from the writer's manual, said to remove these 4 screws, but it didn't point to this one. But anyways, we got the case free now, so we're going to put you down here a minute. Let me see if I can disassemble this and have you be on camera at the same time. I hope you can see that, because when I look over, I'm using my JVC, I look over, my damn head's in the way, so I can't see if you're in view or not. But the case comes off quite easily. And I'm videoing this also so I can get it back together again. Now, once I get the speaker off, I could get at the chassis here. But what I want to do before I even do that is we've got a short in here even when it's turned off. The cover's closed, the radio's off because there's a switch on there. So we are getting a short circuit. I can get the ohm meter out here. Even with the switch closed, so. Well, we're not reading a short on the B plus at this time, but we were. It could be that because the case is on, something is shorted here, and we got to be very careful. We knock the wires off, and we'll be in trouble. So we're going to hook up my ohm meter here. With clip leads. To the B minus, which is right here on the negative of this electrolytic, which I think we're in camera. And we are recording. And to make very sure. And yes. We have got a direct short, and the cover is closed, which means the radio is turned off, because as I said, these radios work when you open the cover, which contains the loop antenna. So we got a direct short. Let's just make sure that we are connected right. Yep, this is the negative, and this is the positive. I always make a plus sign in every one of these radios I work on to make sure that this is the positive and I don't reverse connect it. So there's a wiring error, and you can hear I'm getting some static on there. Probably from this. Yep. So that's encouraging. So we got to find out what the hell happened here, but we're going to recap it anyways. So let me set you back on a tripod here. That's what happens when you fire something up without checking the wiring first. Where current is drawing way too much current. So we're going to have to change that electrolytic. Let's put the power supply back. That hum tells me it's a bad electrolytic. Let's shut it down. We just lost our current draw here. Let's see what's going on. 10 microfarad at 160 volts. This little guy here. We'll put that in there temporarily on clip leads. Okay, what I did here is jury rig a 10 microfarad at 160 volts. But right now we want to see if we get anything out of the radio. So what we've got now is we left the voltage where it was. We're still drawing a lot of current. Okay, but we're drawing a lot of current and I don't know why. We're going to have to get the SAM's more easily read schematic. We're going to have to go through it, so hang on a minute. We should not be drawing more we should be drawing between 10 and 15 milliamps. We should not be drawing any more than like 15 mils. We left this electrolytic unhooked at this time. We've got the speaker loose, but we didn't take out all the nuts yet. We got one in here that we have to remove. And we removed the wire, which is the negative of the battery, which was connected to the positive right here, which is wrong. So we're going to try to find out where this goes, because it does not go here. That's where it was, and that was short number 1. We still have a short here, but it comes and goes. So we replaced the electrolytic temporarily on clip leads. So it wasn't the electrolytic, although you can see here that it has leaked out its electrolyte in the years past. So we're going to try to get this out. The only thing is I have to remove audio output transformer wire, which goes here, and of course I'm videoing this for you guys as well as me to reassemble this properly. And we got another wire for the audio output transformer, which goes on this pin here, which no doubt is the audio output tube. But we are missing the 005 or the 0047 on pin 2 of the 3S4 audio output tube right here. Gotta get my finger here. I can't get the pointer in on these. Right there. So the audio output transformer connects to pin 2, which is the plate of the 3S4, but also it is missing 0047 from pin 2 to ground, which is right there on the schematic. However, we still seem to have a short, but we're going to connect it up. We're going to just use clip leads, and we're going to put all this stuff in. We got to put the 10 microfarad electrolytic back in from here to here, which we're going to replace anyways. I wish I can get an axle lead instead of a radial, but the only axle lead I have is a 450 volt. We're not going to waste a 450 volts on a radio that uses a 67.5 volt battery. It's kind of a waste. We've got a wax capacitor to replace here, and we got a real tight one to get at here. We'll do all that off camera. And we got to test the resistors and so forth. There isn't very much in this radio, but we do have a capacitor block here which contains 4 capacitors, 3.02s and 1.05, that we have to deal with. But right now, let's try to fire this thing up. But for some reason, it does have a short. Now, there is going to be a coupling capacitor, and I really need to get a lot of magnification. It goes to the grid of the 3S4. However, I'm not sure where it is. It could be this one right over here, with my fingers pointing, or it could be this one here. These are the only 2 caps. So let's see what the value of the grid coupling capacitor is, because if that is shorted, that could cause a lot of current drain on the B+. And there is your grid coupling capacitor, 0.005, right there. So let's check the radio and see how much current it's drawing. And then we got to get in and change the caps. And that's not going to be easy. Okay, what I did is temporarily tack in the 10 microfarad electrolytic. That's not the way I'm going to be doing it. This is just a temporary test so that we can probe in here and see what the voltage is. And we're going to try to get at the grid of the audio output tube, the 3S4, and see if it swings positive, which it's not supposed to do. And that would indicate that there would be a leaky or shorted grid coupling capacitor. So right now I'm going to connect up the speaker with clip leads only, and the battery wire with clip leads only for now, because all this is going to be done right when I get it all recapped. And there's only, like I say, there's only 2 caps on the chassis that I can see, other than a mica down there on the bottom left-hand corner next to the wax cap. And then, of course, we got these 4 caps in here, which are going to have to be dealt with and maybe restuffed, because that's the only way you're going to be able to do it. There is a YouTube, there actually isn't a YouTube video, it's on another site, of the Motorola 5A1 lunchbox radio, which if you do a Google search on it, it'll show, but it is not a YouTube video like I thought. Anyways, let me go power this thing up. We'll get my power supply ready. I got to clear this mess out of the way here so I can get at my leads. I'll be right back. Okay, what I got now is I'm going to be applying 68 volts, 67.5, whatever, without the A batteries installed. So the radio will not be drawing any current other than if there's any shorts in the B+, which I detected before. But it appeared to be intermittent. It could be something shorting to the case when I had the case on, because the case is metal, or whatever. Or it could be a leaky audio coupling capacitor that goes from the plate of the audio driver to the audio output tube, which is the 3S4, which is located where that black clip lead is. And that is the audio output transformer, and the B+, I just happen to have a white wire, goes here. There's the electrolytic I put in, and we got a Rube Goldberg set up here, as I always do, with the voltmeter, and we're going to be putting in 68 volts. This is very touchy. I don't have a vernier dial on this. We're watching the current. This is the voltage, but we actually are watching the voltage on here because we can see it easier. So we're cranking up the voltage now. The door is open so that we've got the switch turned on, because there's a switch right down there. That's just an extra lead. It's not going to hurt anything. We're cranking the voltage up to, let's see, something not right here. I think a lead come off. Hang on. We had a lead come off. These are lousy, cheap Chinese garbage test leads. The banana plugs just barely lay in there. They fall out. And that's why I wasn't getting any reading on my meter here. Now, we're cranking up 63. .3 volts. No current draw at all. So we don't have a B plus short. Now, granted, there's no D batteries in here, and the D batteries, of course, supply the voltage for the 1.4 volt filaments of these tubes here. So we're going to put in the D cell. What we're going to do is we're going to shut the power supply off. We're not going to adjust it here. We got 67.4 volts. That's close enough. We'll shut it off. There's a capacitor discharging there. It's only a 10 microfarad, so it don't take long to run down. Alright, so I'm going to put in the 2 D cells and we'll come back on this. I got to do that off camera, but we're getting audio. So, the audio output tube is good, but we're not getting any radio reception. All we're getting is a little bit of noise. So, it could be anything. The oscillator coil, which is right here, may be open. Hopefully not, because there's no way I can rewind it. Could be in the IF cans, or it just could be a bad tube, or one of these resistors are off. So, anyways, we are drawing a safe amount of current. We're drawing 5, 6, 7, I don't know, 8 milliamperes thereabouts. At 67.8 volts. Well, it came to life with a lot of noise when I touched the pins in here. Now I bet you it's from this thing. Yep, and it was from that. Let's see if I can tune it here.
I had a little bit of nerves,
Hey, Wax.
because it is my former team, but, I embraced it, and I was really excited to just be in the moment and pitching against the Yankees as a Red Sox. In that rivalry, it's a lot of fun.
Getting a little howling in there.
Baseball's all about is fun and having a good time and getting the fans involved. And
There's an acoustic feedback.
Were you a little amped up a little bit? Yeah, I was a little amped up. I got a little ahead of myself, and I can't fall behind the guys like that, and especially with this kind of lineup. So I feel like I settled in.
Gotta clean the volume control.
I don't really want that first thing to ever happen again.
Now, this bypass capacitor here are, a lot of them are bypasses. And if a bypass capacitor is open in that capacitor block there, that could cause oscillation too. So this thing is working very well, considering that nothing has been replaced except the electrolytic, which is right there.
Getting 6.5 on the road in Philadelphia, you tease them up to plus.
I have no idea what channel this is, station.
Yes, I am. Yeah. So,
I'm worried Kirk can't move.
You what?
Very good.
I'm worried why Kirk Cousins is having some mobility issues. Just
with the audio, you're going to get a little draw, so the current change is going to be with the modulation coming through. And the louder you got the volume, the more change is going to be, the more current it's going to draw. But that's what it should be drawing.
Not with the regular line, but I like the alternative line.